Everyone, now let's get started. Today we will continue the discussion about the processes. Last lecture, we took a look at the concept of processes. What is a process and what's the difference between a process and a program? The process image or how a process works in the memory. So we have the text section, data section, heap, and stack section. And the most important process is a program in execution. So here process is an active entity. A process change state during execution. So this is a process state diagram. A process can change from ready to running and ready, and also it can change from running to terminated. Also the change the state from new to ready. And the operating system enable the transcript. How to enable the transcript. A process control block for each process. In the process control block, we store the process information, process ID, parent process ID, and the register and memory management information. So the operating system maintains this data structure for each process. Process scheduling, the operating system maintains the ready queue and the blocked queue. All the ready process are stored in the ready queue, and all the blocked process are stored in blocked queue. And then the context switch. So last lecture we stopped here. From one process to another process. So when one process is running on the CPU and this process requests input or this request or this process needs some resource, this resource is not available, or this process need to wait for the child process. Now the CPU need to switch from this process. So when CPU switches process, the operating system must save the state of current process and reload or restore process where the context switch. So the context switch, the operating system will running process state reload or restore the state of new process. Now save the state of current process. All the current process information are in the register. Process use the CPU. So the CPU execute the instruction of current process. When the current process is blocked, the CPU is idle. Now the operating system new process to run on. Now the operating system need to save the state of current running process. Save the information to the process control block in memory. So the information to the reload or restore the state of process. The new process information is in the process control block. Now the operating system read this process control block to register. The new process can use the CPU, run on the CPU. CPU will access process. So the operating system will do this, the switch context, save the state of current running process, and reload the state of new process. The context of a process is represented in the process control block. Process is stored in memory. Is stored in the memory. So the time is pure overhead. Load the information from memory to register and also save the information from register to memory. This is a pure overload. If we have a dedicated operating system and the process control block store a lot of information, we have process P0 and process P1. Process P0 is running on CPU. So the process 0 is executing. Process 0 is running on the CPU. And then the process 0. Now the process 0 requests input-output operation. Now when the process 0, P0 requests input-output operation, now the CPU is idle. Process 0 will not use the CPU to do the input-output operation. So now the P0 release the CPU. P0 release the CPU, so the need to select the new process to run on the CPU. Because operating system doesn't want CPU to sit idle. So now assuming P1 is selected, P1 is a new process, so the operating one to run on the CPU. When P0 locked, okay, now P0 executing and it requests input-output operation, will save the state to process control block of P0. So the process ID, all the register to memory. Because the process control block, this is in the memory. And then after save the information to process control block, and then information from process control block to register. The P1 information are loaded to the register. P1 can start running on the CPU. P1 can start running on the CPU. So now after P1's information are loaded from memory to register, P1 run on the CPU. P1 is executing. And now in this example, after P1 use the CPU for this P1 request the information. So now the P1 CPU, the operating system need to do the context switch, save the state into P1's process control block, and then switch to P0. Now we have two context switch in this example. So switch from P0 to P1, and then from P1 to P0. Here we have the two context switch. The operating system do the operating system switch the context. Okay, now let's take a look at the process programming. How to use system calls to create a process, and how the parent process wait for the child process. And this one means the child process will execute a specific executable program. So today we will try to complete these two and then talk about the command line argument. Fork. Fork is a system call. So we know the system call is an interface to access kernel services or the kernel functions. Now if we want to know how to use this system call, we can check this system call. We can use type this command, we will see the system call fork. Because if we have this fork command by default one, but we don't have this fork shell command. So by default, we go to the section 2 manual page. We can see the how to use the system call. A parent process create child processes, and the child process in turn can create another processes. So this can form a tree of processes. We can use a process tree to take a tree of processes. The first process is a system D, and system D is a parent process of other processes, or the parent process for other processes. I will show you this later. A process is identified and managed where a process identifier. This is called the PID. PID, process ID. Every process has a unique process ID. Operating system uses PID to identify and manage processes. Now we have the system called fork. So now how to use it? We include header file and the fork process ID, return a PID. PID type. In fact, the PID integer. This is this is an integer. Now the fork return an integer. So this process ID and the get PID system call also return process ID. This system call means return the process ID, the current process ID, or the calling process ID. And then we have the get PPID. Here, this means the process ID. Now you can see the difference. This is a get process ID, but this one is a get parent process ID. This system call process ID. It returns a parent process ID. Return parent process ID. Okay, now let's take a look at the first one, the most important system call fork. Now the process calls this process, call this fork. The calling process, we also call it parent process. So the parent process call fork, this system called to process. The new process is called child process. Child process. So the parent process call fork to create a child process. Parent process and the child process, they have different process ID. because in the operating system, each process has a unique process ID. So the parent process and child process, they are two different processes. So they have different process ID. Now here is the fork. This system called create and execute duplicate of parent process. The process consists of a copy of address space of the parent. Okay, now what does it mean? Now, when we have a parent process is stored in the memory. So this part of memory we call the process image, or the address, or the process image, or the memory space. How the parent process stored in the memory, we call it process image. In this process image, this is a parent process image. The parent process image. So this is a parent process stored in the memory. Now, in this process image, we have what? We have the code section, and we have the data section, and we have the heap, and we also have the stack. All process is stored in the memory. And now, when the parent process call the system fork, this system call process. Create the child process. Now, this child process is created the output to this child process. Now, this is a child process image. This is a child process image. The process also stored in the memory. And the child process image is totally same to the parent. So the parent process copy the code section of parent process. Copy this. And also copy the data section of parent. And the heap section, and also the stack. So the child process and the parent process, they have the different memory space, or they have different memory. They have the same process image. That means child process execute the same code of the parent, and also the child process has the same data as the parent, and the same heap, and the same execute the same code that the parent has. Now this is same. So child process just copy all the parent information. And now the different is in the parent process, the fork read child process ID. So we know the fork return a process ID, return an integer of process ID. In the parent process, and in the child process, the fork returns 0. Now, in the parent process calls fork, because the child process has the same code. So the child process will also call fork. But the different process fork return the child process ID. But in the child process, the fork returns 0. Take a look at an example later. And then parent process and child process have their own separate process control block. Each process has a process control block in memory. Operating system maintain the process control block. So the child process also has their own process control block. And both parent and the child process continue at the instruction following the call to fork. The child process and the parent process, after call fork, they will continue at the instruction of after. I will show. Now, in this example, before we talk about this example, let's connect to the Linux lab. Change the font size. Now I connect to the Linux lab. I already connect to the server GBH3-1. Now I connect to the Linux lab GB359-2. Now I connect to the Linux lab. Okay, now the main page. We can see we go to the section 2 because we don't have the fork. In fork, we'll go to the section 1, but we don't have the section 1 for the fork. So we go to the system call fork section 2. Fork create a child process. And then we need to include header file. So in this header file, we find the different types. Now the the PID type is defined in this header file. But in fact, the PID type is an integer, int. So the fork return the PID. Now the fork create a new process by duplicating the calling process. Calling process is a parent process. So we will child process by duplicating the process. The new process is a child process and the calling process is a parent process. The child process and the parent process run in separate memory space. They have separate process image. They have the section, data section, heap, and the stack. At the time of fork, both memory space have the same content. The child process has a copy of parent memory process image or the memory space. The parent process is an exact duplicate of the parent process, except the following point, except PID, except the process ID, because each process has a unique process ID. The unique process ID. And this process ID doesn't match the ID of any existing procession because each process has a unique ID, so it doesn't match any existing process ID. The child's parent process ID is the same as the parent process ID. Okay, so now we now I will not read it. Now I will let's take a look at the return value. Okay, return values here. On success, the PID of child process is returned in the parent. So in the parent process, the child process ID is returned on success. Child process 0 is returned. Fork returns 0. On failure, -1 is returned in parent, and no child process is created. And now I will show you this. exit the menu page. Now let's go back to this code. Now, this example, the file name is a simple fork.cpp. Here we include this header file, and then in the main function we have a local variable x equal to 0, local variable, and then the process called fork. That means this process creates a child process. This means a create process. Create a child process. So this process is a parent process. Parent process create a child process. Now we have two processes. Now, after fork system call, we have two processes. One is parent and one is child. These two processes, they all execute this same code. They have the same variable. So that means the parent process will execute x equal to 1 and print out I'm process, this is my process ID, my parent process is this ID, and my x. So the parent process will execute this for statement, return 0. And then the child process will also do the same thing, because the child process has the same copy of. So the child process will also execute this x equal to 1, and this my process ID, my parent process ID, and x. Now in the parent image, and this is the child process image. Now in the parent process image, we have the x equal to 1. Now x equal to 0. Parent process change x equal to 1. So now in the parent process, we have the x equal to 1. And now in we have to 0 at first, the initial value is 0. Here the child process will also change the x equal to 1. So now we have x equal to 1. So now we get the parent process print out the process ID and the parent process ID, and also print out x is 1. The child process will print out its process ID, parent process ID, and x is 1. Now let's take a look at this example. Now I will. This is a simple code. Source code file is simple fork. VI simple fork.cpp. So now x equal to 0, we call fork and increment x, and then print out process ID, parent process ID, and print out x. Now exit. So first step, we will I will compile this file. I use G++ because this is a .cpp file. Simple fork and -o. I will assign the executable file name simple fork SF. Simple fork. So that means the executable is SF. Now there's no error message, means the compilation is successful. /SF. I run this executable file. Now we can see we have two parts. Process print the first 3 lines, and the child process print the next 3 lines. Okay, the parent process 13816. the 422 and my x is 1. And now the child process print out I'm process 13817. My parent process ID is 13816. You can see that this is process ID is equal to this one. So now we can tell the first process is a parent process, and then the next process is a child process. Because the child process, the parent process ID is equal to the first process ID. Okay. For parent process and child process, X value are both 1. They have their own X. Okay, now this is a simple example. Now we have more example. This is simple fork. But now, for this simple fork, this example, to know it's a parent or the child process, we need to compare the process ID. If it's parent process ID equal to the process ID of another process, we can see which one is a parent, which one is a child. And now this example, BetterFork.cpp, parent process and child process, they can execute the different. We can let the child process and the parent process, they print out the different information. We have a main function, and then we have the local variable child PID. Child PID, the PIDT, in fact, this is an integer. So the process ID is an integer. Now the initial value child PID is 0. And variable X equal to 0. And then a fork. The fork return value is stored in child PID. Now we will check the PID value. In the process and parent process, they execute the same code. In the parent process, the fork return child process ID. But in the child process, the fork returns 0. Okay, now, also if the fork return -1 means there's some error. Now the fork return value assigned to child PID. If the child PID equal to -1, if the child PID equal to -1 means the fork is not successful. The fork system call is not successful. So now the process get PID failed to fork. So this get PID is a calling process. The parent process call the fork, and this system call is not successful. This means we have the error. This system call is not successful. It's an error. And when the child PID equal to 0, the child PID equal to 0. Because when the child process call fork, its return value is 0. So the child process will execute this. X equal to 2, I'm child. Child process will update local variable X and print out I'm the child. This is the child process. And now else. What is else? Else means the child ID is not equal to 0. So it's return a positive integer. So the parent means that this parent process ID. Because in the parent process, the child PID, the fork return a child process ID. It's a integer, positive integer. So the parent process will execute this x equal to 1, I'm parent. So the parent process will update x equal to 1 and print out I'm child. And then this if statement is done. And then we have two statements. Now the parent process and child process both will execute these two statements. So they print out their process ID, and then they also print out their parent process ID, and they print out X value. Now let's take a look. This file name is a betterfork. betterfork.cpp. We have the child and call fork. If the fork system call has some error, we'll print out this message. Otherwise, we go down, we have an if statement. If child PID equal to 0, so the child process will do this. X equal to 2, print out I'm child. And the parent process print out this, I'm parent. And both processes print out their PID and the parent PID and X value. So first step, I will compile this file. I use a default executable. I didn't add the -o and the executable file. Default executable file. I didn't assign. So the G++ compiler will assign a default executable file name. That one is a a.out. /a.out. Now I execute this executable file. Okay, now we can say I'm the parent, and this my process ID, and my parent process ID is this, and my X is 1. So we can see the parent process print out these two lines. And then I'm the child process, and this is my process ID 97. Parent process ID is 971. Now we can see the parent process ID is same to this process ID. And my X is 2. Because the parent process ID set the X equal to 1. And the child process ID set X equal to 2. So they have the different process image. And the child process does not change X in the child process does not change X in the parent process, and parent process also cannot change the X in child process image. Now the child process, this is the child process. Child process print out I'm child, and then print out the process ID, parent process ID and X. And the parent print out parent and process ID, parent process ID and X. Now we can use the if statement. We can use the if statement to set the X, to set the parent and the child they change the x to the different value. Okay, now for these two examples, any questions? And now let's go back to the lecture notes. This is a fork system call. And now let's take a look at the wait system call. Now we have the parent process, child process. And now we have the cascading termination. A parent process terminates. If a parent process terminates, process must be terminated. We have the parent process create a child process, and now when the parent process terminate, we want all the child process terminated first, and parent process can terminate. The parent process must call wait for the termination of child process using wait. So parent process call wait for child process to terminate. Now the wait information and the PID, the process ID of terminated process. So the wait, this system called child return the terminated process PID, or the PID of terminated process. Okay, now the wait system call calls the parent process to block until it receives the signal that any child has finished execution. When a parent process is running on the CPU, its state is running, and then the parent process call wait. This system call to block. So that means the parent process change state from running to blocked. Change from running process called wait to wait for the child process to terminate. So now, after the parent process call wait, the parent process change state from blocked. Change the parent from running to blocked. This parent will be blocked until the child process terminate. Until the child process terminate. When the process terminate, the parent process change state from blocked to ready. Now, the child process is terminated. The parent process change the state from blocked to ready. So we talked about when we see the process state diagram. So while a child process complete or terminate, the parent process doesn't call wait. And now, if the parent process terminate, but the running child process becomes an orphan means no parent. The running child process becomes an orphan, and the terminated becomes zombie. So zombie is not running, as this process is already terminated, but it's still in the system. It still has a process control block. It's still in the system. So it stayed in the system. this zombies will stay in the system until adopted and weighted by system D. Now okay, so the operating system cannot force the user process to always call wait. So some user processes, they don't call wait child process to terminate. So now we may have a system D, the first process in the system, will adopt all these orphans and zombies. So the system D adopt this zombie and orphan. And then the system D, this process will call wait system call. After the system D call the wait system call, this be removed from the system. Okay, so that means a process will not be removed from the system until it is waited, until its parent call wait for it terminate. Okay, now the system D, this process, the first process in the system, will adopt all process without parent, or their parent already terminate. So the system D will adopt all the zombies and orphans, and the system D will call wait system call maybe after some time slice, and then the wait remove the zombies and remove the zombies from the system. Now let's take a look at example. Wait child. We have the main function, and child PID, its data type is PID type, it's an integer, and the status, this int, this kind of status code, and we call the fork system call, and its return value assigned to child PID, and then we have the if statement. If the child PID equal to 0, what does it mean? It means the child PID equal to 0, because in the child process, fork returns 0. Okay. The child process will print out this. I'm process is PID, and my parent is parent PID. So the child process will print out this. And else if than 0, greater than 0, this is a parent process. Parent process will print out I'm parent PID, and my child is child PID. Now this is a child PID. Child PID is a fork. In the parent process, return the PID of child process, or the PID of created child process. And this else is what? This else means the error. Means if the child PID is negative value, this is the error. This is an error. Means the fork system call is not successful. This is if we have the error, we'll print out this process failed to fork. The fork system call is not successful. Now the in the .cpp file, use a cout to print out. Now in the C file, this is the C file, .c file. Now we use a printf to print out a string standard screen to the standard output. Percentage D means we print out integer. Now the get PID, the process ID is printed here. This is integer. The printf printf is a standard C library function. Okay, standard C library function. So that we use it in the .c file. Now this is the if statement. If statement, and then the if statement we have the printf. This means for this printf, the parent process and the child process both do this statement. So the parent code, they execute the same code. So both parent and child process will execute this. I'm process, and this is the ID. Process ID. So we use this process ID, print out this process ID here. And then the /n is a new line. The out and line. In the C++, we have the out and line and a new line. -n here in the C, we use the /n. And then we have the if statement. This is the if statement. Now, if the child PID equal to 0, this means what? The child process will execute this. For this if, the child process will execute this. Sleep 5 seconds, pause for 5 seconds. Out, I'm process ID and I quit. So now the child process second and then terminate. Okay, so it's not terminate yet. The child process sleep for 5 seconds and print out this string and print out I quit this string and then new line. And then the next statement is what? The next statement is return 0. So after the child process execute return 0, child process terminate. Okay, return 0 terminate. And now the else, the parent process will else part because if the equal to 0, but it's not true for the parent process. So the parent process will go with else. Will go with else. The parent process print out I'm parent and I'm waiting for child process and call wait to wait for the child process. Because this parent only has one child, so we don't return the child process ID. We just call wait. And then, so after, now, if the parent process goes first, the parent process will stay here, will stop here, pause here, blocked. The parent process is blocked. And then the child process sleep for 5 seconds out, and the child process return 0. And then the parent process can print out child has already I quit. So we always see this. We say the child process quit, and then the parent process can resume from wait system call and print out this. I will run this, compile and run this. See the wait system call. This file name is a wait child. I wait child. The wait child.c. child PID and status wait, but here we have the wait PID, but we don't need it. Now the full return value assigned PID. If the child PID equal to 0 and the child process will do this. So L child PID greater than 0, the parent process will do this. We print out the error message. So fprintf means print to a file. Print to a file. And then child process will print out process PID. And then the child sleep 5 seconds and print out process this PID, this quit. And the parent process will parent and wait for child process. And then the parent process call wait. After the parent process call wait, it print out parent and my child is this has arrived, I quit too. So you always see this 3 statements, this 3 you always can see these strings are printed out after child process print out a quit. Now let's take a look at this. This is .c file. I use a GCC to compile it. .c. So now I don't executable file name is .out ./a.out. Second, let's take a look at this. Parent. Okay, now we can see the parent process goes first. Parent, and my child is this. The parent is 65. 65. The child process is 66. Okay. Process. Now the parent process print out this. This is in the if statement. Here. In the if statement. Okay. Parent process goes here. Goes first. The parent process print out parent and child processes. And then the parent process execute process print out process ID. Process, and this is my process ID. And then the parent first process goes to the next if child process. So now this means that the parent process goes here. Okay, the parent process goes first. It starts this 2 statement and then print out this information. And then it goes this if statement, it goes to the else part. Parent, I'm waiting for child process. And now parent process call wait. Okay. Now we go here. This means after this statement, the parent process calls wait. So the parent process goes first, and then it calls wait. And then it calls wait. It calls wait. The parent process is blocked. The parent process is running. Process is blocked. When the parent process is running, the child process is ready. Okay, the child process is ready. Okay. Now, the parent process is running. The child process is ready. When the parent process call wait, when the change from running to blocked, child process change from ready to running. Okay, the child process change from ready to, now the child process, I'm child 66, so we can say this is the child process. And my parent process is 65, this parent process. And then, okay, now this statement is here. I'm process this, and my parent process is this. This is from the first if statement. And then after the if statement, we have this. I'm process 66. This is from, the parent and the child process both execute this statement. Because it's not in the if statement. It's after the if, after the first if statement and before the second if statement. Next one. This is a second if statement. The child process, I'm process 66. So 66, we know this is a child process. I'm process and I quit. So I quit, the child process will execute return 0, means the child process terminate. Child process termination will do what? Will change parent process state from blocked. Okay, because the parent process is blocked because it is waiting for the child process to terminate. Now the child process terminate, return 0. The parent process change from locked to ready, and then the parent process change from blocked to ready, and still 3 statements left. So when the parent process change from ready to running, when the process is dispatched on the CPU, the parent process will print out the last sentence, or the last one is I'm parent, my child has arrived, I quit too, and then return 0. Parent process terminate. Okay. This is a wait. This is a wait. Still the parent goes first. The parent child is 21. This is a first if statement, and then this is the after the if statement, and then this is the second if statement. The parent process do this, and then after the parent print out, I'm waiting for the child process. The parent process call wait, and then the parent process is blocked. Change from running to blocked. And then the child process change from ready to running. The child process run on the CPU. The child process print, I'm 21, my parent is 20, and I'm 21, and I'm 21, I quit. And also here, the child process sleep for 5 seconds. And then the child process print out, I quit. And then after I quit, we have the return 0. And then the child process terminate. Parent process change from blocked to ready. And then it's ready, and then the scheduler selected dispatch to the CPU ready, and then it changed from ready to running, and then it run on the CPU. It print out the last statement. I'm parent 20 and my child is 21 has arrived. I quit. The wait system call. After class, you can try this. If the parent doesn't call wait, what happens? If the parent doesn't call wait, and you will have a zombie in the system, and then the system D will wait for this adopt and wait for this zombie, remove the zombie from the system. But it's transparent to users. So when we write the program, if we call the fork system call to create the child process, we need to, it's a good habit to call the wait to wait for the child process to terminate. Okay, so we always use fork and then wait. Because we don't want to burden the system to adopt this zombie and wait for this zombie. And this is a wait. 8 minutes now. Okay, so far for the fork and the wait. Any questions? Okay. This is the next one is a command line argument. We know the command line argument, command line input. So a command line consists of arguments separated by white space. The argument contained white space is surrounded by double quotations. Now, if we want to read the command line argument, we need to add this parameter. We need to add this parameter in the main function. So in the main function, we add this parameter argc. So int argc and parameter star argv, this is an array. So argc is a count of the number of the program name. Now, I will give you an example. Now for example, I have the command line, I have the executable file name a.out. F1, F2. A.out is my executable. Now, I want to execute this executable program and also add the 2 more command line arguments. Now, I have 1, 2, 3. I have 3 command line arguments here, and they're separated by white space. This is a white space. This is the white space. Now I have 3 in this example. Argc is 3. Argc is 3. Argc is a number of command line argument, including the executable file name. Argv is a array. So you can think Argv is your array of strings. Element I of the array is a pointer to the I string on the command line. Now we use this example. String, this is the third string. They are separated, use white space. Now the argc is 3. This is 3 because we have 3 command line arguments in this example. And the argv 0. So start from 0. Argv 0, it stores the string. It is a string /a.out. And argv 1 is the second string, 1. And argv2 command line argument is f2, is the third string. Okay, this is how we argument in the argv, this array argc, the number. For example, in the homework 2, we will use this a lot. So this is important because we use it in the homework 2. This is one example. Now let's take a look at another example. Now, another example is this. This is a command line argument. Now we have 4 command line argument, and the ./main is a 4th command line argument. This is the executable file name or the program name. Program name is main, and then the second command line argument is file1, and then file2, and then file3. So we have 4 command arguments in this example. They are separated by white space. They're separated by white space. We have 3 white space separate these 4 strings. So now in this example, the argc equal to 4 because we have 4 command line arguments. And then argv0 store pointed to this string, or you can think the argv0 store the 4th string, ./main. This is the executable file name. argv1 pointed to the next string, file1. argv2 pointed to the string f2, file2, and argv3 pointed to string, file3. Now here we can see that the argc equal to 4, so the argv index is from 1. The argv, this array is 0 to argc minus 1. The argv, this array, its index is start from 0 and end at argc minus 1. Now in this example, it starts from 0 and the maximum index is argc minus 1. 4 minus 1 is 3. Okay, now the argv0 always store the executable file name. And argv1 to argv1 to argv3, these are the other command line argument. So normally gv1 to argc minus 1. The other command line. Now we have example. We will take a look at example next lecture. Okay. Here we will take a look at this example next lecture, and then we will take a look at the homework 2. Homework 2 is a part 1 shell, toy shell. Use the C shell. Thursday, I have office 12 noon to 12:15, and also office hour on Monday morning. But today is a in-person example. If you have any questions, you also can email. I will see you.
One question, Professor. Is there for Linux we need a different C, or they've got a C in the shell C? Means they've got a whole library when you write it down?
Hear you clearly. Can you repeat?
when you want to writing the program on the shell based on the C, they've got a library, they've got a compiler, or we have to install the compiler to the Linux.
The which homework? Homework 1 or homework 2?
No, homework one is done already. I submitted for homework 2 about the C because all of them are programming on C.
Yeah, homework 2, you can, I have example, my program written in C, but you also can do the homework in C++. Yeah.
Okay,
Examples
thank you, Professor.
to C. Yeah. Yeah, other questions?
No, thank you.
Close